So the Mixed Reality Toolkit Solvers. If you're not already aware of the Mixed Reality Toolkit, the main SDK for building applications for the HoloLens, I suggest you quickly go and check it out. It contains lots of lovely components. We'll be using one collection of those, which is the solver system. So in this tutorial, you should walk away knowing what solvers are, what kind of solvers there are in the Mixed Reality Toolkit, where you should use each one, and what are the limitations of that, and how to go about implementing it into your project. You will need to build 4 scenes. Each of them will have a visual component and a behavioral component, which will be the result of one or more solvers. We're going to look at orbital radial view, surface magnetism, momentum, and in-between solvers. Just go over a couple of terms first of all. Spatial Understanding, or as it's known, Spatial Awareness in this version of the toolkit. This has more information than the spatial mapping mesh and references that mesh in order to take actions. It groups together all of the environment interactions that you have, and it is often, but not always, a bounding box for the Playspace. That is the volume you have to work with in AR once you've done your initial scanning in the application. It's important to define this because it works as a reference frame for the physics and other events that happen. You can find more information and the documentation for solvers in these links, and there's also plenty more you can learn going through Stack Overflow and other online sources. So solvers, what is a solver? It's essentially an optimization algorithm. It's a set of commands that's looking for the best solution given a set of constraints. For example, if you want to find the lowest point on a surface, you can move across it until something satisfies that condition. Because they're iterative, they tend to be quite computationally heavy, so keep that in mind if you're adding lots to a scene. Here are a list of the solvers we're going to be looking at in this tutorial. The first one is fairly self-explanatory, but can be made to give a game object the behavior of orbiting the camera, a hand position, or some other reference point. Radial view works in much the same way, but it works with the view cone, so the forward direction also of the game object, which would be useful for leading or trailing objects. Surface magnetism works directly with the spatial mapping mesh. If you wish to pin objects to that mesh or to the floor, etc., then you can do that. Momentum is an interesting solver because it takes into account the current speed of the object, and an in-between solver keeps an object in between two others. So we're nearly ready to get started with making some content. First, let's get a scene set up. So I'm using Unity 2018.4.20, which is almost the latest minor release of the long-term support. Mixed Reality Toolkit 2.3.0, which is the current release, and Visual Studio 2019, which is a good improvement over 17, in my opinion. So once you've got the scene set up, you want to import the foundation package, and that link can be found previously in the slides. You want to create profiles. You'll be prompted to do this. You should allow the toolkit to set up as much as possible, and you need to make sure your camera input and spatial awareness systems are activated. The build target will be Windows UWP, as are for all HoloLens applications. And you also want to make sure in the project settings that you've got your application name set and any capabilities you want to use are enabled. Finally, you want to add the mixed reality parent to the hierarchy. I also thought I would include here the editor controls when working with the Mixed Reality Toolkit. This sometimes a little bit clumsy, but see what you can do. It does save a lot of time not having to build all the way to the device, or even in fact to the emulator before you test something. So here you can find a list of all of the important actions. Hopefully that will be helpful. Let's go to Unity.